So now after all the types you went through, value types, reference type, mapping types, we have a small example called simple storage right here for you to kind of practice on things you have learned and understand how to apply types in a more practical settings, something like this. Let's go over to Remix. We will be using Remix in this case for us to really get hands-on into how to create these, how to work on these things, right? So let's go over to Remix. If you haven't had Remix yet, just go to remix.ethereum.org. Then next, you just create a new file. Let's call it simple storage.sol, .sol, Solidity. Right. First thing you do is you get the license. Right. You have SPDX license identifier. And yeah, I just put MIT for now. Then you need pragma, right? Pragma solidity. Let's do over 0.8.20 for this case. Right now, I think solidity is like decently far. We can check this one. It's like 28, right? 0.8.28. But you can do above 20 for now. We just go contract, simple storage, right? This is how you declare contract, and empty, you save it, works, right? Compiles everything good. Now let's go inside, right? First, let's imagine this is like a simple storage, and let's initialize some small variables. For example, I want to show maintainer name myself, right? I want to declare a variable called maintainer name to show people like I'm the author, I'm the maintainer of this contract. Let's do, and it's a string, right? My name is a string, so let's do a string. Visibility is public, so people can call it maintainer and name equal to the extent, right? And make sure you have this semicolon at the end. So that's how you declare a variable, right? You can save it, compiles, good, right? When you click Command S for macOS or Control S for Windows, you see that this you see Remix automatically compiles for you, and then it just show you the green, like a green tick mark right here. So yeah, so it works, right? And then I want to show the version. I said let's go next one. I want to show the version of this contract. Let's do uint 8 because it's not that many. Version equal to 1, right? Something like this. Right, save, works. Now I want to get some donation from you. So what I can also do is donation address equal to something, and go this one, copy this, right? And remember I told you to set up your MetaMask. You can just copy it straight in, an address in would work. This is my developer address. You can feel free to donate over. Now let's get into the meat of it, right? This is a storage contract, so you want to store something, right? Let's store an information of a person, right? For example, let's say, and for financial reason, let's say we want to create a struct, right? Because this person has a bunch of informations that's a bunch of different types, right? Let's do a struct, and it's called person, right? And then you do something like this. Now, don't worry about the red marks. Once you fill it out, everything is gonna work. Now we want the person, you want a name, right? So you put a string name, right? That's gonna be the name of the person. Then you want an age. It's a uint 8, and it's gonna be age. Why? Because your age is not gonna be negative, and also you're not gonna live above integer 8, like 8-bit integer for it, right? So uint 8. Next one is I want to check if the person is over 18. So yeah, boolean over 18. All right. I want to assign a UUID, and the UUID is gonna tie to the address. All right, so you have address, UUID, all right, because it's enough a unique ID. Then I want I want to assign how much asset the person is holding. So you have asset value, and I have another int 256, which is debt value, right? All right, so asset's gonna be positive, and your debt value is gonna be negative, right? You can you're gonna be in a negative. Then okay, now let's go to the next part. Okay, so now you have your struct. Let's initialize an array of person, right? Because you want like a list of people, and it's gonna be private list of people. Okay, why I do private in this case? We're gonna have a function. We're gonna have a getter function below, and that getter function is gonna expose. It's gonna let you query this list of people, and then so I put it private, and we use the getter functions to make it public. And so then I put it private here, so it doesn't create two different functions. Essentially, creating two functions do the same thing. Essentially, the next one we want to do a mapping. All right, let's do a mapping, which I would tie an address to a person. All right, and this is UUID to person. Remember, remember over here we have a UUID right here. So this person information is going to contain a UUID, and then this one will be a mapping with between an address and a person, right? So this person is tied. So an address will be tied to a person, and then inside that person will also contain the information, related information of the UUID of that person, right? That's why I have UUID to person. Now let's create a function to store a person. Now you have everything ready for you to start adding information in. So let's create a function for you to store a person. Right? So store person. So when you pass, so now let's do this one. So I want to add. So first variable here is gonna be a name, and it's gonna be string, right? So let's put name string like this. All right, unit age, and you have bool over 18, right? Over 18, into 6 asset value, and into 56 that value. Okay, why this syntax, the underscore? Basically, it's like just a small convention, essentially tying the input of this to this variable. It's just a convention. It doesn't really affect how the code runs. It's just a convention. That's pretty much it. All right. So now you have public returns person, and let me try to go with this, and I'll explain to you some of the issues. Okay. So now when I cap off this functions right here, so after I edit the input and the output, everything, you see Solidity compiler start marking these two as red. And if you hover it, you see a type error. Data location must be memory or code data for parameter in functions, but none was given. Right? What is this case? So string type and struct type requires you to have a location. Because it's not the native type, right? It's just a combination of type. So it requires you to have a storage location for it. So in this case, you can put a memory for this one, right? So because I just want this to be, why I put memory? Because I'm not gonna save this name, because the name is gonna be saved inside a struct, right? Which is a global variable here, state variable, right? It's gonna stay saved inside a contract globally. As a state variable. That means I don't need to save another version of it. So then I just use as memory. So then this input will only be stored inside memory, and then after the function is finished, it's just gonna remove it. Right? And for the output, yes, you also need to specify the storage locations, which is also gonna be memory, because it will only has that thing when you finish running the functions, and after that it's discarded. It doesn't mean it will remove the struct here, by the way. It just means that after you return it, it's just a function to clear out the values basically for that functions, not the storage over here. All right, so let's go a little bit. Let's go next one. All right, so we will have now. So I input everything in. Now in Solidity, everything is within Solidity, on the unit will be following Y, and weight is a unit in Ethereum, and it's gonna so basically it's 18 decimals. One ether will be equal to 1 to the power 18 weight, and weight is basically everything. Like so you so that's how everything needs to be converted. So on your numbers, on your inputs, everything numbers for integer and unsigned integer is everything is gonna be in the unit of weight. So say you put 1 here. If when you render it up, it's gonna be 1, but then it's gonna be, if you compare that to, it's actually 1 way, not 1 ether, and it will create issues where things are, and keep in mind in terms of decimals, this one might create issues for you. Right? So, but in this case, let's just do something like this for you to demonstrate to working with variables inside Solidity. I want to convert all of the input here for asset value and debt value into ether instead of using weight. Right? So it's gonna be I would do the syntax 1E18. This essentially is saying the asset value is gonna be equal to asset value multiplied by 1 to the power of 18. Right? This syntax, it's equal to this. Like this. Oh yeah, we don't want that. Somebody with something like this. But do you have a shorthand, which is this? Okay. Oh, there. And you can also have debt value, right, equal to this and 1E18. Right. Now I want to add people information into the array. So what I want to do, I have list of people. Right? Remember, we initialize this array. And I push people's information in. And it's going to be person. Right? So remember what we did the declaration before. We can also do name tie with the value. So then let's do that for clarity. Right? So if you want to do something like that, you do the syntax like this. Name like this. You have age, which is like this, over 18, You have asset value, and asset value. You have debt value. Alright, something like this works. Oh, there's also UUID. 1 second. There's the UUID, which is right after the boolean. Let's keep it in the right order just so it works. Alright, so you're gonna have UUID will be equal to message sender. Alright, so the person calling this function, right, it's like sign up, right? Think about it like signing up. So a person a person calling this function will be assigned a message sender. So essentially, think about it as like a form. You're asking people to input their name, their age, are they over 18, and then their address that they use to call this function will be assigned as a UUID for this person, right? And then you have something like this, and now what you do is you go for, and then I want to do the mapping. So UUID to person, and I'm gonna do message sender. So I want the mapping, right? So everything exists. So then basically I'm saying in this mapping, right? If I pass in this mapping, will map the address of the person that calls this function with the the person over here, right? You will tie that in with this one right here, like that. So now when a person calls this function to sign up, immediately the information will be input into a struct to store neatly, which is think what is like their file, and then it will have a unique ID that ties to that. So next thing you know, you can always just query the address, and then it will return the information of that person, right? And you go return, person, and of course you just repeat this one. So then, after you finish, the function will return it. So then you have something nice for you to look at. That's just basically for us to confirm, right? Otherwise, it would when you call the function doesn't return anything, and then you need to call it to check. Right? So this just make our life a little bit easier. All right, so let's go to the next part. So we finished the store person function. Let's get another function to retrieve the person, right? So we call it retrieve person, and now we pass in an address, right? Address, and that address will return us the person because you have the you have the mapping, right? Very simple. So then you returns person. Remember, memory person, and you go here, return UUID to person address. This, all right? Straightforward. All right, so you compile, everything works. Now let's go to this screen, right? Go to deploy. Let's show you this one. So compiler. So now you see here, I'm choosing 0.8.26 to compile. Right? You can also use 0.8.28. That's okay. I think we specify this to be over 20. 0.8.20. Anything above that, no issue. So 26 is no problem. Just pick that for convenience. And then you can go to deploy, right? Let's go to deploy, and let's deploy these functions. All right. So you select here. So you have all these things. Remix VM. So this one basically you're deploying this in a virtual environment within Remix. And it's not going to be deployed in testnet. This the virtual environment, it's like everything's instant. You have tons of money here. You have tons of ether for you, and they always give you 10 accounts for you to do whatever you want with it. Right? And you select the contract you want to deploy. In this case, which is simple storage, and you just click deploy, and boom, it deployed for you. Right? Everything works super fast because it's a virtual environment, so then it's super fast. Right? So let's go into the simple storage part. All right, so you have these functions. So Remix is super convenient. It gives you an interface for you to interact with this one. So here you have the simple storage interface here. You can and you remember we have these functions. You have these variables: maintainer name, version, donation address, those ones. So now you can do something like version. All right. And then when you call version, it will return you 1 because we initialized it 1 here. Call maintainer name, returns my name, zxstim. If I call donation address, return my address right here. Right? These two match. Now let's try to store information. Right? Let's put my name. Right? zxstim. I'm 30 right now. I'm definitely over 18. It's gonna put true. Asset value, let's say I have I don't know, like put in like 10, right? Let's say I have like 10 value of something, like $10 in my name, and my debt is let's say negative 2, right? Negative 2, and I can click transact, and then it will push the transactions, and it will put transaction like this. This is a format transactions, right? So you have the output right here and the input right here. Here's the decoded input. There's the input that I pass in, decoded output, and this is what it returns me, right? Remember inside your function, store person, it returned the struct of the person. So you see the struct right here is a tuple of zxstim, 30, true, address, my asset value, and my debt value, right? So that's how it returned. And that's it. You just store my information inside a contract. Now let's retrieve that information, right? So let's go to this retrieve person function, and I copy in my address. I copy the account, and I put it here, and I make a call. And we also return a tuple. Right? We'll return the struct that I put in, which is zxstim 30 true, my address, my debt, my asset value, my debt value. Right? Very straightforward. So that's how you would apply your typing knowledge into Solidity in this case, right? So feel free to play more with these functions, right? Start adding manipulate functions more, creating more complex data types, creating more advanced person, or maybe multiple different type, right? Like person, you can also have another one called professions, and then you linked person with professions, and then you start adding more information in. So feel free to play around with starting with this simple example. Play around with it, have some fun, and we will keep going with the next part of the bootcamp.